Hi there, welcome back to Joko's Workbench, and welcome to part 3 of my little Sharp PC1500 series. In this episode, I will show how to get programs onto this machine and dig into the quirks of programming it in BASIC. In the last 2 episodes, I got the machine working and the pens for the printer writing. Throughout these episodes, you saw some program examples already, and luckily, it is not hard to get code from modern computers onto this old machine. The CE150 interface has 3.5mm jacks for audio in and out, and it comes with a cable to connect it to tape recorders. My machine actually came with this beautiful Sanyo TRS-80 mini cassette recorder. But as usual with tape machines from the 80s, it is not working because the belt has perished. I will probably fix it in the future. The cable can just plug into a modern computer, of course, and so let's do that. There are websites made by retro fans that have programs available for download as WAV file, and I downloaded that game here for testing. However, when I played the file, the Sharp computer did not manage to read it. I opened the file in Audacity and saw that the waveform is offset to one side, and my sound card might not like that. I moved the waveform into the middle and tried again. That worked, and I could see that the program was transferred correctly. There's a toolkit available for Windows and Linux that can convert text into compatible sound files and back. For loading text files, 2 programs are needed. One converts text into a binary format, and the other one that format into WAV files. The Linux version comes with a long, quite complex looking shell script, I guess to be compatible with different Linux versions and pocket computers. In my case, it was enough to run the 2 programs here subsequently and play the file, and that simple script here does the job just fine. Surprisingly, the CE150 docking station doesn't even need to be plugged into power to transfer data, at least when the PC runs on its batteries. I am a biodata analyst by profession, and so I wanted to program a little data analysis example. Let's say you have a cloud of data points, and you believe that this cloud is not random, but the mix of data points from 3 processes with slightly different average outcomes. Now you want to know where these so-called clusters are located, and which dot belongs to which cluster. There's a beautifully simple algorithm called k-means for that, and it can be explained in just 3 sentences. Place 3 cluster centers at random locations in your cloud, and then assign each dot to the closest center. Now change the position of each center to the average position of the dots assigned to it. Rinse and repeat until your centers don't move anymore. I implemented the algorithm in R and wrote the code in the same way as I would write it in BASIC. That meant, for example, implementing things like average and the Euclidean distance using for loops. Then I transferred the code into BASIC. There were some unexpected hiccups actually, because it seemed like my variables were overwritten at random spots. Here's an example for that. It took me a while to find out why that is, until I read the manual again and realized that the basic dialect used here uses only the first 2 letters of a variable to identify it, so that, for example, pose x and pose y are the same variable. This is why all my variables here have only 2 letters. I used some simple tricks to make my code more readable, besides obvious things like indentations. There are no structural elements such as logical blocks or functions in BASIC. Everything is line numbers, goto and goSub. This basic dialect here does not even have an and if. I helped myself by inverting the if statements so that a single goto command can create a readable if block. This is the whole program, and now let's run it. Watching the algorithm doing its thing was fun. Especially the distance calculations are very slow, because of the multiplications and the square root calculations. Each iteration took about a minute, but at the end I got the correct result. And I had a lot of fun writing that code and to see what a 40-year-old pocket computer can do. That is all for this time. Thanks for watching. Please subscribe and see you next time.